Hi everyone. Today we will be learning the commonly used data types in Postgres. Now, why is this important? This is important to learn because whenever you want to create a table in SQL, you will need to define the data type of each column depending on the type of data you would like to store in that column. Okay. Now, what is data type? Data type defines the type or kind of data a column can hold. What do we mean by that, guys? Let's say, for example, I want to create a table of that contains, say, student information. Okay. Now I have a column that says student ID, first name, last name, and age. These are the different columns. Okay. Now let's say this first name, right? We know we want to store the names of the student, then this is going to be string. So in that case, I would like to specify or define this column to be able to only hold string data types. Same thing with last name. Okay. Also, like for this student ID, we could say, okay, I want this to be an integer. Okay. Also, this could be serial. We are going to see what serial means shortly. Okay. So what I'm doing right here is I am defining the type of data that I want each column to hold. Take, for example, age. Age, right? We know age is number, right? So in that case, I want this column to hold numbers, okay? Which is going to help us to be able to hold the age of the student, okay? Also, the data types also determines the operations that can be performed on the data. What do we mean by that? Let's say, for example, this age column, we want to add 2 to each of these numbers, right? Because this is a data, because this is a numeric, or because it is a number, it's easier for us to just add 2, because if I add 2 to 35, it becomes 37. I add 2 to 20, it becomes 22. Okay, so that is what data type is. It defines the type of data or kind of data that a column can hold. Okay, now what are the commonly used data types in Postgres? Take note, there are more than this, but the ones that are commonly used that for you that you're probably going to start with are these ones, especially these first 4: numeric types, character types, date time types, Boolean types. These are the major 4 you are going to be starting with. However, in the next couple of videos, I will also like to show you what JSON types and arrays also are, because there are some cases in the real world that when you are creating your table, that you want your column to be JSON, okay? And in some cases, you want your column to be arrays based on the requirement, based on what you are trying to solve, okay? But for this video, we are going to be looking at numeric, character, date, or date and time types, then Boolean types, okay? All right, I hope you guys get this right now, okay? Now let us go to our Google Chrome or your web browser. Okay, go to Google and then you can just search for Postgres documentation. Then you can just put data types. When you click enter Postgres documentation data types, you see the first link that it gives you, that's the documentation of Postgres, right? If you go right there, you see what I have right here. These are the data types. For me, I'm going to close this because I already have it opened in this tab. You can see we have different data types right here: numeric, monetary types, character types, binary, date time types, Boolean, enumerated. You can see we have different kinds of types right here: JSON types, which I just mentioned, arrays. You have different data types right here. But like I said, we are going to be dealing with just 4 in this video, okay? And then I will show you how to create tables, how to create a table with these data types as well. You can also go through this. This is talking about the names of some of those data types and their alias. So that means if you want to use big ints, you can also specify it as this int 8, that's the alias for that. Or if you want to have character, you can have it as car. You guys are going to see that by the time we want to create such table. Okay, but let us quickly go into the numeric type. Okay, the numeric data type. These are the different types of the numeric data types that we are talking about right here. And what does the numeric data types do? It helps to define numbers. It defines integers or floats. Okay, so that means that when you have a column to be a number, it could be an integer, or you want it to be a float, that is when you're going to be using these numeric types. Okay, and these numeric types also have different types of numeric right here. You have the first one, small int. Okay, and if you also look at the header right here, you have the storage size. That means that each of these numeric types have their own different storage size. Okay, now what does small int do? Whenever you want to have numbers between this number negative 32768 to this number, then you're going to be using small int. Okay, so it ranges from this to this. Also for integer, it ranges from this to this. You can see that if you have a data type called integer, it gives you a larger range of numbers to be used, right? So big int, you can see in big int you have this one. This is bigger than integer. Okay, all right. Then if you're talking about decimal, numeric, real, and double precision, these are basically good for whenever you want to define floats, that is decimal numbers. You can see right here it says up to this digit before the decimal point and up to this digit after the decimal point. And take note, decimal and numeric, they are basically the same thing, as you can see right here in this definition. Okay, now if you are talking about real data type, you say 6 decimal digit precision. This is when you're having 6 decimal digits. But if you are talking about double precision, you have it as 15 decimal digit precision. You can see that double precision has more storage size than the real, which is 4 bytes. Okay, another one I would like to quickly talk about right here also is serial. In this case we have small serial, and big serial. You can see right here the description says small auto incrementing integer. Okay, this one says auto incrementing integer, this one says large auto incrementing integer. What does this mean? What that means is that if you want a particular column to be increasing steadily, say take for example you want it to be auto incrementing. Take for example you want a particular column that each time you insert a table, that column should give you 1. Then the next insert should be 2, next insert should be 3, next insert should be 4, next insert should be 5. Then at that point you can be talking about using serial, just like I was showing here in my PowerPoint right here, like this student ID. You can see that this is incrementing 1, 2, 3, 4, 5, right, 6, 7, and then it goes down. So if I want it to be automatically increasing, right, at that point I'm going to be using serial. Okay, I'm going to be using serial. Okay, now however, the type of serial you then use would determine what range of numbers you're going to get to. So let's assume that in my table I'm expecting to have something less than this number of students, 32,767. Let's say I want to have 30,000 students. At that point I can decide to use small serial. But let's say I want to have at least 50,000 students, right? Or let's say I want to have between 50,000 and 100,000 students. In that case I cannot use small serial, I will use serial, because if you look at it, range from 1 to this. And take note, this serial are also mostly used as primary keys. I've taught 2 primary keys in my previous video. If you have not watched that, I encourage you to go watch that. Okay, now, and serial is mostly used versus using small serial or big serial. Okay, very good. That is that about numeric types. Now let us get into character types. If you're talking about character types, you'll be talking about what you call character varying, or you call it varchar, for short. We also have character, or you call it char. Now if you look at this, you have n in that bracket. What that n specifies is it specifies the maximum length of that character. Okay, so that means that if I want to have first name, right, I can specify that for this column, which is the first name, it should not be more than, I can say, 150 characters. Okay, if I say it should not be more than 150 characters, then I'll just put 150 in this bracket. Okay, now if you look at the description, it says variable length with limits, whereas for character it says fixed length, blank padded. I would encourage you to come read this part right here. It says if the string to be stored is shorter than the declared length, values of type character will be space padded. What does that mean? What it means right here is that let's assume that when you are defining your column, you said for character, you said the n should be, let's say, 150. That means you are saying that the maximum length should be 150. Okay, now if you now want to put insert record into that particular row or that column, if you type in James, and as you know that James is JAMES, that's 5 characters, right? So that means that the 5 characters are going to be stored plus blanks plus space, because it's going to be space padded, because you have defined this to be 150 characters, right? And you have typed in James, or you have inserted James, which is 5 characters. So 5 from 150 remains 145 characters. Those 145 characters will be space padded, right? So that is why I say fixed length. This will want to make sure that it stays with that length that you have given it, 150. However, if it were to be character varying, what will happen is that it's going to store James and it's not going to pad it with space. So what happens is that using character varying or varchar helps us to save storage space. Why? Because for this character, this one will have fixed length, because you have specified it to be 150. It will always want to make sure that it is 150 characters. That means that if you, even though you have James, it's going to pad the remaining number of characters that you did not type anything with space or with blanks. Okay, but for character varying, it's not going to pad anything. It's just going to insert just those 5 characters. Okay, now that is what we are talking about right here. So basically, character varying is what most people use, okay, because you want to save on your storage space. Now if you find yourself that you want to have a particular column in which you, let's say you want to have a comment column, you want your user to type in a lot of text, at that point you are going to be using text data type. Okay, and that's why it says variable unlimited length. I hope you get that right now. Okay, now you also have date time. Okay, date time. As you can see right here, you have timestamp. It says without time zone. In this case, you're going to have both date and time, no time zone. If you are, you can also have timestamp with time zone. In this case, it's going to be both date and time with time zone. Then if you have dates, it's going to be only date, no time. Then if you have time, it's going to be only time of day, no date. Then you could also have time with time zone, right? Then this one is going to be with time zone. This one not with time zone. Then you also have what we call interval. So when you talk about interval, it helps to store time interval. I hope you get that right now. Then the next one I would like us to talk about right here is Boolean. If you are talking about Boolean, Boolean is just a true or false state. Okay, in that case, if you look at what we have right here, you could say true or false, you could say yes or no, you could say on or off, you could say 1 or 0. I hope you guys understand this right now. All right, let us go to pgadmin and let us just create a table where we are going to be using these data types to define those the type of values or data you are expecting in those columns, and then let us insert some data right there. Don't worry, also in the next couple of videos I'm going to be making, I'm going to be actually teaching you how to actually create tables, but today I want to just give you an overview of how to create table. Now let us jump to pgadmin. Let's jump to pgadmin and create a database and also a table in that database. Okay, so when you open your pgadmin, then you can come to databases right here, right click, come to create database, click that. Okay, and right here I'm going to give it a name, student. I can say student underscore test underscore 1. Okay, I will leave the owner to be Postgres, and then I will say save. Very good. You can see right here, guys, that right here we have the database already, student test underscore 1, student underscore test underscore 1. If I come to schemas, I'll come to schemas, come to tables. If I try to open this table, you can see we don't have any table right there yet. Okay, but now on this table I can right click and go to query tool. Okay, because now we want to create a table inside this our schema right here. Okay, I'm just going to do a copy and paste right here for you guys, and then I will explain what's going on to save on our time. Okay, but so if you take a look at this, how do you create a table? Like I said, this is going to be an overview. In the next couple of videos, I'll be teaching you how to actually create tables and also insert data. We are going to be looking at it in more details. Okay, where we are also going to be using primary key and foreign key, but in this case for today, we are not doing that. We are not doing any constraint or primary key or foreign key. Okay, so now all you have to do, you have keywords that you need to type if you want to create table. You can say, you say create table if not exist. That means if it doesn't exist yet, create this table. This is going to be the table name. Also, you could decide to take this out and just say create table, student table. That's the name you want to give your table. But it's always a good practice to put if not exist, because if you just say create table this, let's say this table is already in your database, right, and you are also clicking create table again, then you are going to have an error, but you don't want that, right? So because of that, it's always good to put this clause right here. Okay, create table if not exist. This is the table, then you open a bracket. Okay, and then let us specify the names of the columns. Student ID. Okay, let's give it a data type. Remember, I mentioned serial to you just a few minutes ago. Then I call it serial. And why am I using serial? Because I want this student ID to auto increment. Okay, I want to auto increment 1, 2, 3, 4. Okay, for every insert, I want it to auto increment. Then I have class ID. This class ID, I want to put it as integer because I want to specify this class ID myself. I'm using integer, which I just showed to you guys right there. Okay, which I just showed to you. Remember, you have integer. This is integer right here. It can go up to these values right here. Okay, now first name, I call it varchar, and then I say 180. So 180 basically is the maximum length that this name can take. That means for some folks that have a very long name, then we want to still be able to catch that, right? We still want to be able to store that, and that is why I put it at 180. Okay, just to be safe. Okay, so then you also have varchar for last name. Okay, like I said, varchar is used mostly, right, because if you use character, then that means that you are not really saving on your storage space. Okay, varchar is better to use. Then height, I'm giving the data type of numeric, same thing as weight. So it is the requirement of what you are trying to do that will determine what data type you want to use. Okay, so I'm trying to use different ones here for you so that you can better understand what I am doing. If you look at this is the column name, date of birth. I'm giving it a date, data type, date. Then email, I'm giving it varchar. I also make it 80. Okay, tuition paid, that's the amount of tuition paid. I'm giving it numeric. Okay, I'm giving it numeric. Then is tuition paid? I'm giving it Boolean. That means as the student paid, is it true or false, or yes or no? Then the date tuition was paid, date tuition paid, I'm giving it timestamp. And remember, I told you right here that timestamp is going to involve, is going to be both date and time. Okay, so let us run this and let us see if we can create this table. Remember again that this schema right here, we don't have any table right here yet. So I'm going to run this, execute. Very good. You see it has created table. Let us go right there. Take note, you have to come right here to this table and right click and do refresh. Then you left click to refresh. You see now I've refreshed. You can see I have my table now, student table. I have created that. I will go into my columns. You can see these are the columns that we have created. I hope you guys understand this right now. Very good, guys. I'm going to delete this now, and we are going to insert some records into that table. I'm going to type it out right here. I'm going to paste it out right here. Okay, so that I don't keep typing. So the keywords for you to insert is, you're going to say insert into, then you put the table name. This is the table name that we want to insert, and then you put the names of the columns. Remember that we had those columns there before, right? We had those columns. Let me paste this back just so you guys can see what I'm talking about right here. Remember, we had this column: class ID, first name, last name, height, weight, up to date, tuition paid. Now you realize that I omitted student ID. I was supposed to put student ID right here, guys. I was supposed to put it right here in the first space right here, right? But I did not put that. Why? Because this data type is serial. And remember what we said serial is? We said serial is auto incrementing. Same thing as small serial, same thing as big serial, auto incrementing integer. That means it is automatic incrementing. So I do not need to put it right there. Okay, also remember that all these columns, you also have to put them accordingly. You have to put them in order that you have created them here. Okay, and the same thing applies to these values right here, because if this is not in order with these values right here, then you are going to be having an error. So you want to make sure that the order you have here is the same order that you also have right here in these values. Okay, so you are inserting into this with this value, right? So if I have class ID is 1, first name is John, last name is Doe, so, and it goes like that. I will delete that, and then you can see, just follow it. You see email is this, tuition paid 25,000 is tuition paid. I said true. Date tuition paid, I gave it this date right here, date and time. Right now, and that was because that was timestamp for the date type, for the data type. So if I run this right now, execute, you can see it said insert one records, right? So we have one records right here. So now how do we confirm that? If I do select star from student table, if I execute this, you can see guys that we have one row right here, because we have executed one. So you can see we have class ID to be 1 because we gave it 1 right here. But the student ID, even though we did not put it here, but we see it right here, because like I said, it is going to auto increment. Okay, you can see that we have all this. If I insert this same record again, I insert it again, and then let us do select star. You can see I have it has auto incremented to 2. All these other values are still the same, right? If I do it 3 times, 1, 2, 3, so we should have seen it auto incrementing to 5. You see, 1, 2, 3, 4, 5. you can see that these values here are still the same because I didn't change the other values. I hope you guys understand this right now. Okay, now what about if I change? Let's see what happens if I change this tuition page. Remember this tuition page, we had said it was numeric, right? What about if I change this to a string? Let's say I change it to I, right? Let us run it. Let us see what happened. Let us try to insert that record. Execute. You can see here, guys, that there is an error. It says invalid input syntax for type numeric. What does that mean? What that means that our data type that we had defined was to be numeric, but you are putting a string, you are putting a character. Because of that, it returned for us an error. Okay, you can see how that works. It's the requirement of your task or your project that determines what how you are going to define each of those columns. Take for example, in this case, we are talking about the tuition that is paid by the student, and we know that it should be numeric. Okay, if we put this back now and then run it, or let us even put a different number, let's put 30,000. Let us insert our record. You can see it has successfully inserted, right? Let us check just to verify. You can see 30,000 right there, and you can see that we have auto incremented to 6. I hope you guys now understand these different types of, or these commonly used data types that we use in Postgres or even in SQL in general. Okay, all right guys, if you are new on this channel, I will highly encourage you to subscribe to our channel and click on the bell so that you can be notified whenever we release any of our videos. Remember, this is a series of Postgres that we are working on, and we want to have it from the very beginner level to the advanced level. All right guys, I'll see you in the next class. Bye.